In the diagram, triangle ABC is equilateral and point D is inside triangle ABC, so that triangle BDC is right angled at D and has DB equal to DC. If ABD is X, what is the value of X? Let's blow this diagram up since it's at the heart of our diagram. So this is 90 degrees right here, so that means this angle is 45 and this angle is 45 because those are equal since we've got an isosceles triangle. And then since it's equilateral, then that means that this angle is 60. So that means that's 60 and that's 60. Well, that X plus that 45, therefore, is equal to 60. So that means X is 15. Bin has 20 quarters worth 25 cents each. Abdul has 20 dimes worth 10 cents each, as well as some quarters. If Bin and Abdul have the same amount of money, how many quarters does Abdul have? So Bin, it'd be 25 times 20. So 20 quarters each worth 25 cents, and that's 500 cents. Abdul has 20 dimes, which is 10 cents each, plus 25 times X. We'll let X represent the number of quarters that he has. So this is 200 plus 25X. And what they're saying is that these two are equal, the same amount of money. So 500 is equal to 200 plus 25X, and therefore 25X is equal to 300. So X is 300 divided by 25, which is 12. So 12 is the amount of quarters that Abdul has. Suppose that A, B, and C are positive integers with 2 to the power of A times 3 to the power of B times 5 to the power of C equal to 36,000. What is the value of 3A plus 4B plus 6C? First thing we need to do is break up this 36,000 into its prime factors. So I believe it's 2 times 2 times 2 times 2 times 2 times 3 times 3 times 5 times 5. And you can easily figure that. I think there's another 5 in there times another 5. You can easily figure that out with a calculator. Just divide by 2 and then keep dividing by whatever you feel you can divide by. So if you arrange this nicely, it's 2 to the power of 5 times 3 to the power of 2 times 5 to the power of 3. So if you look at that, that basically means that A is equal to 5, B is equal to 2, and C is equal to 3. So that should be no problem to figure out. 3A plus 4B plus 6C. So 3 times 5 plus 4 times 2 plus 6 times 3. And that's 15 plus 8 plus 18, and that is 41. Ali plays a trivia game with 5 categories, each with 3 questions. She earns 1 point for each correct answer. Interesting. If she answers all 3 questions in a category correctly, she earns 1 bonus point. So I'm assuming now the pronunciation is different. Ali answers exactly 12 questions correctly and the remaining 3 questions incorrectly. What are her possible total scores? Okay, let's see here. So we've got to just figure out how many scenarios there are. So we can have five categories, right? So we got category 1, category 2, category 3, category 4, category 5. So 12, the only thing they give us is 12 questions correctly and 3 incorrect. Okay, that's really all there is. So I just have to talk about the different scenarios, I guess. Okay, the first scenario would be if all incorrect were let's see here, 5 categories with 3 questions each. Okay, I got it. So the first scenario would be all, I'll just put wrong, W for wrong, in one category. So all the others would be correct, and that would make us have 12 correct if you count the C's, and 3 incorrect, exactly what they want. So now we have to figure out the points. So she earns 1 point for each correct answer, and if all 3 questions in the category are correctly, she earns a bonus point. So 1 point, 2 points, 3 points, plus a bonus point, so 4 points here. And then 4 points here, 4 here, 4 here. So it'll be 16 points if the scenario is like that. Okay. Another scenario would be if you had 2 wrong in one category and the 3rd wrong in another category. So now let's fill in all the other C's. And let's see what we have. So this would give me 4, 4, and 4, but this would only give me 2, and this would only give me 1. So it'd be 12 plus 3, which is 15 points. So 15 points if it's like that. And then the other, of course, is if the wrongs were in 3 separate categories like that. And then if you fill in all the C's and then count the points, we will have 4 for this guy, 4 for this guy, 2, 2, and 2. So that's going to be 14 points. And I believe that's it. So they are asking what are the possible scores. The possible scores are either 14 points, 15 points, or 16 points. The absolute value of a number x is equal to the distance from 0 to x along the number line, and is written as x, absolute value. So, for example, absolute value of 8 is 8, absolute value of negative 3 is 3, absolute value of 0 is 0. For how many pairs AB of integers is the absolute value of A plus the absolute value of B less than or equal to 10? Let's start off with some cases and let's see what we get. So, first, if the absolute value of A is 0, to ensure that this equation is valid, it would mean that B would have to be either negative 10, it could be negative 9, negative 8, all the way to the other side, 9 and 10. And that would give me 21 values. 21 values. So you have one value here, one value here. So the number of pairs, total pairs, I'll put that over here, would be 21 for this scenario. Got it. So we continue in that fashion. Now let's do absolute value of A equals 1. So that means A would be either 1 or negative 1. So that's 2 values for A that I'm looking at. And then B, to make this equation valid, or inequality, or whatever you want to call it, it's minus 9, minus 8, all the way till 8 and 9. And that, I believe, is 19 values. So the total number of pairs, 2 times 19, which is 38. Okay, so I'm just going to keep going because you may not be seeing a pattern yet, because I don't see a pattern yet. So how about if A is 2? The absolute value, I should say. So that means A is negative 2 or 2. So that's 2 values. 2 values. And to make that equation up here valid, B would be either negative 8, negative 7, and then all the way to 7 or 8. That is, I believe, 17 values. So the number of pairs would be 2 times 17, which is 34. Okay, I think we'll do one more, and that should be able to allow most people to detect a pattern. How about absolute value of A is 3? Now A is either 3 or negative 3, and then B would be minus 7, minus 6, all the way till 6 or 7. That, I believe, is 15 values. So 2 times 15 for this guy, and that's 30. So as you can see, it goes down by 4 each time. So that basically means that the total, if you kept doing this, all the way to the very end, which would be absolute value of A is 10, A would be 10 or negative 10, B would be just 0, and this is 2 values, 1 value, so 2 times 1, which is 2. So it would basically be a scenario where you have this 21 this 38, this 34, this 30, and you go down by 2 every time. So 26, 22, 18, and so on, all the way down to 2. So it would be 26, 22, 18, 14, 10, 6, and then 2. So you add these all up. So 21, 38, 34, 30, 26, 22, 18, 14, 10, 6, and 2. If you add them all up, you would get 221. And that is the total number of pairs that would satisfy that inequality. A sector is cut out of a paper circle as shown. The two resulting pieces of paper are curled to make two cones. The sum of the circumferences of the bases of these cones equals the circumference of the original paper circle. If the ratio of the lateral surface areas of the cones is 2 to 1, what is the ratio of the volumes of the cones? All right, so we have a lot to discuss here. Let's start with just some basics. The radius here I'm going to label R. The I guess distance from there to there, that distance I will label X. And they told me something important here. The ratio of the lateral surface areas of the cones is 2 to 1. Okay. So that actually is very important. I'm just trying to think how to include that into my formula here. So let's go with that. The ratio of the lateral surfaces of the cone is 2 to 1. Okay, so that means this formula that they've given us, pi rs. So pi, let's say the first one is R1. Let's see here. Yeah, pi r, and then S is the lateral, this lateral slant height, which would be R based on what I've labeled. And then for the second cone, again pi, but this time it's a different radius, but the lateral slant will be the same. And they're saying that's 2 to 1. So that basically means that R1 is equal to 2R2. R1 equals 2R2. So now let's look at the circumferences. Circumference of any circle is pi 2R. Now the first circumference will be pi 2R1, and the second circumference will be pi 2R2. Now they're saying that the sum of the circumferences of the bases equals the circumference of the original surface, original paper. So that means that C, the big C, which would be all the way around this initial circle here, that's equal to C1 plus C2. So pi 2R is equal to pi 2R1 plus pi 2R2. Now, this is very important, so we can plug that in. So that means this is pi, R1 is 2R2, so this would be 4R2. So that basically means that C1 is equal to 2C2. Oh, hold on, let me think about this. Yeah, C1 is equal to 2C2. So if this is C1 right here, instead of X, I probably should have just called it C1. Or actually, no, that smaller one I've called C2 actually, and the bigger one, let me use a different color, is this guy here. That is C1, and C1 is equal to 2 times C2. So that basically means that this angle is twice that angle. So if this angle, let's say, was theta, this would be 2 theta. And since the whole way around is 3 theta is equal to 360, that means theta is 120. So that's really important. That's a very good thing to figure out. Move on. Let's see if I can get a little bit more information. I think from this guy here, I can. I'll be able to get that C. Let's see here. well, actually, it's actually this equation right here. The pi's cancel, so I just, and the 2's cancel, so I just have r is equal to r1 plus r2, but r2 is equal to 2r2. So r is equal to r1 plus, or actually rather, 2r2 plus r2, and therefore r would be equal to 3r2. Okay, I'm not sure if that helps me, but it's always good to have that. All right, so let's try to keep everything in the same screen. So this is 120, and this is C2, and this is C1. Okay. All right, so let's see what we're going now. Moving ahead with pretty much the same equations, we've got C is equal to C1 plus C2, and then C would therefore be 4 pi R2 plus 2 pi R2, and therefore C would be equal to 6 pi R2, and then the C is pi 2r, 6 pi r2, so therefore r would be equal to 3r2. Okay, great, which is exactly what I got there. So I'm pretty much, I think I did double the work for no reason. But then we can use this fact to figure out that r is equal to r2 would be r1 over 2, right? So r1 over 2. 3r, yeah, that's correct. Okay, so I guess we got a little bit more done. Okay, so now finally I think we can turn to our attention to what they're actually asking for, which is what is the ratio of the volumes of the cones. Okay, so the ratio of the volumes of the cones would be the volume of the first cone over the volume of the second cone. Now the ratio is, the formulas is 1/3 pi r1 squared times height, and for the second one, same formula, 1/3 pi r2 squared, and I'll just give it h, a small h. When you get rid of the 1/3 and the pi's, you're just left with r1 squared times big H and r2 squared times small h. Okay, now eventually these obviously are letters, so we got to get rid of them, which I think we can. Well, the first thing I noticed is that we can use this substitution here, this guy. That will help. So R1 is 2R2, so plug that in. And that will allow us to get rid of something. This will become 4R2 squared H over R2 squared small h, and then therefore that just reduces to 4H over H. Okay, good. We're still not done, but we've come very, very close to being done. All we need is some sort of a substitution for the two H's. Okay, so then this is where this diagram comes in. I will put that over here since we want it in the same page, because you know you have to use that diagram sooner or later. So this diagram, so if I'm looking at the big H, this is the big H, and the big H corresponded to R1, right? Yeah, R1. And then this was, the slant was R. The slant was this R that I put right here. For both circles, actually. Interesting. Both cones is what I should say. Okay, using Pythagoras, we can get a Pythagorean relationship. H squared plus R1 squared is R squared, right? And then H squared. Well, R1 and R, we have the relationship here. Sooner or later, it's going to come in handy. So R1 would be 2R over 3 squared. And therefore, this looks like H squared is 4R squared over 9 R squared. So H squared would be 5 5 r squared over 9, I believe. Yeah. Okay. And I'm going to try to do the exact same thing for the smaller cone, where it would be small h, and then this would be r2, and this would still be r. So it would be h squared plus r2 squared is equal to r squared. So h squared plus, okay, where's that formula between r2? Right here. r2 and r. So it would be r over 3 squared is r squared. So h squared would be, I think this is r squared over 9, so it would be 8 r squared over 9. Okay, I think we got it. So we go back and we substitute this in. 4 times h, well, h is going to be root 5r over 3. And then the small h is going to be the square root of 8, which is 2 root 2 r over 3. Okay, we're almost done, I believe. So 4 root 5 r over 3, invert and multiply 3, 2 root 2 r. The r's cancels, the 3's cancel. We're going to have root 5 over root 2 and 2. Okay, and if I rationalize the denominator, I'm going to get root 10. Okay, and then what did I oh, this was the ratio. This is the ratio of the two volumes. So I guess it's root 10 to 1. Yeah, I believe that is the solution.